IP addressing is really easy once you know how to do it. By the time we're done here, we will explore the purpose of an IP address, subnet mask, and default gateway as it relates to general network design. And I've got to say, this is where I get that gut level, real excitement for you, because we're not only going to unlock the doors of IP addressing in this skill and the next few skills that you're going to learn, but I feel like unlock networking in general for you, because IP addressing is essentially the glue that ties everything together. And as you get this, it's almost like all these light bulbs. I can see them going off right now where it's like, oh, okay, and that, and it's almost like things are just going to come alive. So let's start off by looking at the network diagram that I've used in a number of other skills as we've built things together with 3 sites: Arizona, Florida, and Nevada. And I'm going to go a little less bubbly and a little more practical with the network diagram right now, because I want to take you into what I've done so far, into the skills up to this point, and then what I need to do moving forward. Because up till now, I've been using what I would call temporary IP addressing at each one of these sites, as I've assembled the network devices and put a base configuration on them, and et cetera, et cetera. A lot of the other skills that I've used as I've built around this topology, I just had to have some IP addresses in place. And I gave 192.168.1.0 to Arizona, and 2.0 to Nevada, and 3.0 to Florida, which were essentially placeholders. Because in a way, I'm not going to say this is a rule, but it's kind of a mark of shame to use those IP addresses in business networks, because 192.168 for probably the last 20 years has been what home networks use. It's when you go to Best Buy and buy a cheap little D-Link router for your house and you plug it in. That's the subnet that it's going to use by default, because it's intended for extraordinarily small networks that don't really have much potential to grow beyond their smallness. When I see one of these in use in a business network, I think, okay, whoever designed this probably didn't have much of a mind for networking. And I'm so sorry if you've deployed a business network with that kind of network, or you work at an environment that has that in the network. I'm not making any judgment whatsoever, but what I'm saying is this doesn't scale. We need to have a new addressing that allows you to scale to larger environments. So let's start off with, what is an IP address? Essentially, it's a numerical address that is 4 bytes long. We are used to seeing these 4 values, 4 numbers in a row, where each of these numbers can be from 0 to 255, thus giving you 256 total values. But as we relate to it in terms of computer storage, each one of these is 1 byte. Now, that may have thrown you off for a second. Relate to it in terms of computer storage? I mean, how computers look at size. I just said this is 1 byte of information, because that's how most of us human beings are used to seeing values on a computer, is in terms of bytes. And when I say byte, most people immediately go, oh, well, like a megabyte or a gigabyte, or even a terabyte, because you've purchased a computer before, you looked at the specs and you saw how much RAM and hard disk space. And I'd say, yeah, that's kind of what I'm talking about. If you were to go down the scale, you would have your kilobytes, which is 1,000 bytes, and your megabytes, which is 1,000 kilobytes. And then, you go down to your gigabytes and terabytes. And I mean, this just keeps going all the way to yetta and zettabytes. I mean, it just gets crazy in terms of the amount of size. But where we're going, as I give you a sneak peek of the road ahead of you, it's not actually further down in size, but further up in size. Because you and I work in terms of bytes. It's the first, I'll say, human understandable things. I'll say, roughly speaking, a byte equals 1 character. And that's a really rough way of saying it. Like, for instance, if I were to open Notepad and type the letter A, that's 1 character. B, that's now 2 characters. So 2 bytes of information is there on the screen. C, 3 bytes of information. You get the idea, right? Well, when it comes to numeric values, a computer with 1 byte of storage space can actually represent any value from 0 to 255. That's why, if you ever wonder and look at IP address, why did they only go to 255? Seems like 99999999. Something bigger would have been a better way to go. Well, that's because 1 byte is comprised by 8 bits. That's where I'm going smaller with this. And what is a bit? It is the most fundamental piece of computer code. It's when you think of, how the original computers worked, on-off switches, dip switches, right? When you look at people with computer programs that were written in the early days, like my father would go to college and write computer programs on punch cards and punch out little chads and so on. It pains me as I even say my father. I just got a message on LinkedIn on one of the social platforms where somebody said, "You remind me of my dad." And I'm like, oh man, you had to say that. But that's what a bit is. It's an on and an off, a 0 or a 1, and there are 8 of them. It ruins this whole scheme because we've got, 1,000 here, 1,000 here, 1,000 here. Actually, technically 1,024 bytes inside of a kilobyte, 1,024 kilobytes in a megabyte, and so on and so forth. But when it comes to bits, we have 8 of them. 8 zeros and ones that go into each one of these bytes. And that's why I'm saying this is kind of like a sneak peek, is I'm giving you a preview of where we're going with the IP addressing, because right now I just want to work in the decimal world. And in that world, an IP address is simply 4 numbers. So let me just clear this off a little bit and erase my chicken scratch. And now bring in one more puzzle piece. Let's just say I've got an IP address, 192.168.1.52. Sound good, right? That's one element of what a device needs to successfully communicate on the network, but the next puzzle piece puts some of that together. It is the subnet mask, and I'm going to type in right up the default subnet mask right here of that IP address. It's 255.255.255.0. That subnet mask serves a computer to let it know which portion of its IP address represents what network it's on, and what portion represents which host it is on that network. And while we're talking in this world of bytes right now, the simple decimal world, I would simply grab a pen. And if you're taking notes, please do this on your paper. Just grab a pen, use a different color if you can, and just draw a line right down where the 255s line up. Wherever you see a 255 lining up with the number above it, that represents the network. And wherever you see a 0 lining up with the number above it, that represents the host. So no one would speak this way, but this is technically accurate. If this IP address was assigned to a computer, I could say, this is computer number 52 on the 192.168.1 network. Now, why does this matter? Really, why is this important? Let me first off say that's the right question to ask, because it otherwise just becomes a whole bunch of numeric nonsense to us. Let's talk about it practically speaking. If we have that computer in the Arizona network, let's just say it's 192.168.1.52, and it has a subnet mask of 255.255.255.0, that allows this computer to become smart. It's now able to recognize who is on its network and who is not on its network. So if I go on this computer and I access or ping or try to do something that tells this computer to reach 192.168.1. We'll just say 191, the computer looks at it and it goes, okay, whoa, hang on a sec. Let me see. 192, okay, that's my network. Yep, that's okay. 168, yep, that's my okay. That is computer 191 on my same network. I know that I can just walk out the front door and be like, "Hey, 191." I can remember his IP address. "Hey, 191, how's it going? Come on over for a barbecue. The day is nice because we're all in the same network." And that's the human way of saying it. The computer way of saying it is I can scream into the wire with an ARP message. You guys remember what an ARP is? Address Resolution Protocol. It's a broadcast, right? I can scream into the network wire and say, "Hello, who is 192.168.1.1?" And that computer will be assured, as long as it's turned on and working, it will be assured to receive my broadcast, and it's going to recognize I'm host 52 in its same neighborhood, and it can broadcast and communicate right back to me. That's how they know they can communicate directly. But if this computer tries to access 192. I won't even go with 192. Let's just say 11.1.1.1. Let's go crazy, right? As soon as we try and access this, and let me just make sure we're all on the same page. Why would we access that? Oh, I don't know. Maybe we go to cbtnuggets.com and the DNS server says, oh, cbtnuggets.com is 11.1.1.1. Your computer's like, oh, 11.1.1.1? That is totally not on my network, right? Because I'm on the one, like as soon as it looks at the first octet, by the way, that's what these are called, an octet. As soon as it looks at the first octet, it's like, the 11 is not 192. I can't scream and get there. I can't yell out, hello, 11. No, it's not going to work because it's not in my neighborhood. It's not on my network. And that's where it needs that third puzzle piece of information. And I know you know what that is because I know you've been in the Windows world before. If I open the properties of any network adapter, I see the IP address, the subnet mask, and the default gateway. Three elements that always combine together to make our network devices work. The default gateway is the element that allows my computer to know where to go if it needs to get off of its network and get to another one. And practically speaking, this is the router of the network. And that's the whole purpose of the router, is to allow you to communicate with things that are not on your network, because it's going to look at its routing table and figure out how to reach said IP address of 11.1.1.1, because that's what routers do. That's their resume. That's their job description. I know how to get places. That's what I do. And if I don't, I'm going to drop your packet and you're going to get an error message on the screen, because I am your gateway of last resort. I'm where you go when you try to reach something that you don't know how to reach. So if this computer doesn't have a default gateway, it's not going to have any hope of reaching that 11.1.1.1 address. It's just not going to get there. But since it does, because I just wrote it on the screen, it's going to go, okay, I'm going to send an ARP message, not for 11.1.1, because I can't scream and get there. I know that. I'm going to send an ARP message for 192.168.1.1, who happens to be the router, and the router will do the work of getting me there. So I don't want to dive into routing and its functions and all of that all over again. There's a whole other skill on that. What I want to talk about is this is why we need to properly understand IP addressing, is because it's what helps us design the networks. So when I go to Arizona and I say, okay, I need to set up some networks so that they're large enough, I have enough IP address to address all of the clients inside of this network. And it's not valid anymore. I mean, we live in a modern, hey, let me just clear all this out for real quick. If I were to see a network like this, I would say that's probably, I don't know, 100 employees, maybe 50 employees. And I would immediately go, no way, 192.168.1 will not work for that. Because we used to live in an era where I could say each person is like an IP address, right? Because they have their computer. But I've got my cell phone that has an IP address. I've got my IP phone sitting back there next to a plant. I've got my my thermostat on the wall that has an IP address. Like, we live in a world. The printer, the server, I just have to twirl around the room. This one human being, Jeremy Char, right now in this room, probably has 20 IP addresses just for me. So if that's in my little home video studio right here. If I were to go into a production business network where we have a gamut, like I froze for a second. I'm like, I don't even know what word to describe it. Everything is online. It's the Internet of Things, right? People's watch. By the way, your watch, if you have a smartwatch, it actually has an IP address. It joins itself to, I mean, people are walking networks nowadays. So those 254 IP addresses that would be included in that 192.168 isn't enough. And that is going to lead us into the next discussion as we look at how can we grow our networks beyond just that 192.168.1.x. And this is what leads us into the discussion of subnetting. But for now, you understand the purpose of an IP address, subnet mask, and default gateway as it relates to general network design. We have to have that foundation, and then we'll get into more. For now, I hope this has been informative for you, and I'd like to thank you for reviewing.